Welcome to the session. Trust you're all doing well. And so let us discuss some of the questions related to ML practice. So maybe these can be used for Databricks certification and all. In the general project discussion also, these things are very much helpful. Let us try to understand few questions. Hmm, 1 minute, guys. Let me pick the questions. So these questions are maybe mixed, some basics would be there, and sometimes we may have some sort of metrics and all these things. Okay, right. Coming to the first one, generally, guys, after practicing these kind of things, still we'll be getting the questions like what is the distinction between supervised and as well as the unsupervised. Okay, so let me paste the question along with the answer also so that we can have a look on that. So generally, guys, while discussing the machine learning kind of the perspectives, there are certain specifications like, so we will be working with some sort of the algorithms, and there exist mainly two sort of the algorithms we have seen. One is the supervised and second is the unsupervised machine learning. So basically, friends, in the simplest way, how I can define this particular supervised aspect is in supervised machine learning algorithms, we have to provide the labeled data. That means suppose in terms of the labeled data, so I would say, suppose I'm here, I'm giving the employee experience and employee qualification and current pay. So these are all the appropriate labels. Based on this, I can fix the CTC in the new company or maybe for the new designation, something like that. So here the labels are pretty clear, like employee experience, qualification and pay. Based on that, we can predict the new things. Okay, so this is how you can refer the labeled data and prediction of the stock market prices. All these things comes under the category of the supervised, where we are having the label information, and based on that we are going to compute the values. Apart from that, we are having one more category called the unsupervised, where we need not have the labeled data. For example, classification of the emails into spam and non-spam. The example is like that, guys. Suppose we are having always the common example I use it to give, like some kind of the customers data, where we are having the customer age, customer income, and their purchase. Okay, this is the information we are having. Now, observe here, guys, there is a specification like, like I'm having the uh, income and as well as the how much they have spent on the purchase. So maybe they're having $1,000 income, $3,500 or $10,000, like that some sort of the income is there. And accordingly, the spendings also maybe some sort of the groups we found here. Okay, and the some members, though they're having mid-range income, they're spending less. And these guys, okay, we are having multi specification here. Few groups are here and few groups are there. Actually, this is not giving any outcome, guys. Like this is giving some patterns. Actually, I can say this is cluster 1, cluster 2, cluster 3, cluster 4. Now, the marketing team want to engage or want to connect with these kind of the customers. So in that particular case, generally they have to focus on this area, guys, because these members are having the high income. Okay. These members are having and the high income, but spending is low spend. So the thing here is, guys, specifically there is no need of labeling these things as an outcome or something. Uh, Generally, if you consider the unsupervised learning provide us some sort of the observations, knowledge. We can draw the knowledge from the data, or else you can pick up some kind of the patterns. This is the way how you are performing the orientation of this thing. Okay, so that is what how you can refer the supervised and as well as the unsupervised. Let me pick some other question. This is the most commonly asked question, guys. It is bit stringent. Stringent in the sense, sometimes, if you are not aware of these kind of asks, maybe you may be giving some other kind of the answer. Okay, so let me put this way. Yes. What are the parametric models? Give an example. Friends, here in the programming languages, we generally see that suppose if I'm taking the function, I'm giving some kind of the arguments or parameters to this particular function. Parameter is nothing but whenever I'm changing the value, okay, the outcome is also getting changed. That is what you call the parametric. Now, according to the machine learning, what do you mean by a parametric model? So parametric models are those with a finite number of the parameters. Okay, to predict the new data, you only need to know the parameters of the model. Only that particular parameters, based on the corresponding parameters, you can develop the model. Friends, here regression models are generally the parametric approaches. They follow the parametric approaches, and even linear SVMs also belongs to the parametric approach. Parametric in the sense we are assuming something, and there are some limited number of the finite number or limited number of the parameters to submit, and accordingly, just we need to build the corresponding model. They are all friends here. If you observe the regression, and already we have discussed about the assumptions in the regression. So while implementing some sort of the queries, while implementing some sort of the linear regression models, just we have to follow some kind of the conventions. Okay, so just if you consider these kind of the assumptions, okay, then we need to adopt with that particular model, and accordingly the model behaves based on the parameters. So in a single liner, parametric model is something which is expecting some finite number of the parameters, and of course it is going to predict based on within the given number of the parameters. The best examples, regression algorithms, as they are having the assumptions so as to implement the appropriate task. But whereas if I'm talking about the non-parametric are nothing but those with an unbounded number of the parameters. There is no limitation of the parameters, allowing for more flexibility. And sometimes some of the parameters may be optional, some may be the, uh, you know, some may be the hyperparameter tuning, all these kind of things. To predict new data, you need to know the parameters of model and state of the data that has been observed. Okay, it's a dynamic kind of thing, friends. We cannot say that only these parameters or these particular values are going to decide or give the outcome. But rather, what we are doing is here, just we are not restricting ourselves with few parameters. Rather, we are working with unbounded. Okay, there is no limitation on that. So the best example, decision tree, k-nearest neighborhood, and topic modeling. Okay, and LDA, kind of all these kind of algorithms belongs to the non-parametric approach. Generally, friends, compared with the parametric, okay, there are higher chances for getting the best predictions for the non-parametric only. Okay, so just have a look on that and remember the examples. Parametric, generally the regression, especially the linear regression. Okay, just this is having some sort of the assumptions. Non-parametric decision trees, LDA. Okay, these are all examples of the non-parametric. Let us see some other questions. where this particular question is related to the classification and regression. So though we study generally, okay, while starting your career as a kind of the machine learning engineer or whichever, so definitely we have to observe some specifications related to the classification and regression. And if someone asks us, just we also say that, okay, classification, which is nothing but yes or no kind of thing, regression, which gives the values. And if I need to give some example in terms of the classification, I'm having the decision tree classification, random forest classification, k nearest neighborhood, support vector machine, naive Bayes, all these things. Regression in a way, linear regression, multilinear regression, polynomial regression, all these things belongs to the regression model. And we pretty know that logistic regression belongs to the classification because it is the outcome of that logistic regression is yes or no, and it is belongs to the classification model. Now, all these things let us put in a nice format. Classification is used to produce the discrete results. Okay, and classification is used to classify the data into some specific categories, true or false, yes or no. For example, classifying emails into spam or non-spam, etc. Whereas the regression analysis, when we are dealing with continuous data, for example, predicting stock prices at a certain point in time. Now, let me take one example of the classification, friends. Okay, so we are having the qualification, maybe BTech, and we are having 5 years of experience in some sort of the MNC, and you worked on the data engineering and data analytics. Now we are applying the machine learning engineer position. Assume that. Now through HR analytics, we can find out whether you are going to crack that interview or not. Okay, yes or no kind of thing. So these aspects, guys, just they are giving us some sort of yes or no kind of the things or true or false, etc. Okay, whereas in terms of the regression, the same scenario I will take. Okay, with your qualification BTech, with 5 years of experience in the MNC of DE or DA, how much pay you are getting? Maybe pay range or something like that. So in dollars, I have to find out the appropriate pay. Okay, see here, this is the value. Finally, we are getting some sort of the value and that particular value given by the regression model. Okay, so if your scenario is expecting the true or false, yes or no kind of the separation, then you can go with the classification. Whereas regression is something like, so just it is taking some input data and applying some sort of the um, algorithms on that, and we are coming up with some outcome. So that is what you call the regression. Moving ahead. Now, yeah, most important question, guys, here, because many at times, in the certification exams and in the projects also, we have to focus on this particular thing. That is nothing but the overfitting of the data. Okay, let us try to understand what do we mean by overfit and how we are going to avoid that. Friends, in the simplest way, suppose your model is really doing well in the training, but it is not doing well in the testing, that your model is a overfit model. Okay, in a simplest terms, in a single line, or if you want to say, in training, your model is really performing some 92% accuracy, something like that. Whereas in testing, the same model end up with 78 or something. There is a huge differentiation of between training and as well as the testing of the data. So your model is understanding the training phase in a better way, and it could able to achieve the reasonable benefit or predictions. But whereas friends, in terms of the testing, just it is not performing as that much. So there is a gap. There is a performance differentiation between training and as well as the testing. So in a single liner, I can say this is the This is the way how I can define the overfitting. But whereas in the more generic way, where any machine learning engineer or you want to explain to a functional user, then overfitting is a situation that occurs when a model learns the training set too well. Is not learning actually, it is by hearting something. So just it is observing every input data and it is trying to imitate that rather than learn, taking up random fluctuations in the training data as concepts. Suppose if suddenly if any value is changing, it is taking that as also one kind of observation. So these impact the model's ability to generalize and don't apply to a new data. Friends, here in our life also, just if you are more generalized and we may not respond to the specific kind of things. So if you are making use of these training data too much and your model is strictly specifically following that particular thing, then it is overly learning. Okay, so obviously, if any suddenly if it is seeing the new data, like when a model is given the training data, it shows 100% accuracy, technically a slight loss, of course. But when we use the test data, there may be an error and low efficiency. This condition is known as the overfitting. So in the training, your model is a super model, but whereas in the testing, it is not behaving like that. So that is a huge performance and behavioral differentiation between the uh, training and as well as the testing. So there are multiple ways of avoiding overfitting, like guys, regularization, penalization, some kind of aspects where it involves a cost item for the feature involved with the objective function. Um, there we can fine tune the parameters and handling the techniques, and moreover, guys, adding more data to the training is also resolves the issue, because as we are not giving the entire data um, automatically, guys, just it is performing like that. And moreover, if you add some more data, definitely you can empower your model with a proper input. That is one of the solution. And making a simple model with lesser variables and parameters, the variance can be reduced. This is the situation, guys. Like, every data scientist or ML engineer need to understand one thing, like there is no rule or there is no proper regulation to follow the rules or something. Rule book is not there, guys, because in the projects what we'll do is just based on the situation, based on the requirement, just we need to fine tune the model. So similarly here also, every time rather than opting for a complex model and end up with overfitting, always better to go with a medium or simple model, then obviously we can get the better outcome in the testing also. And moreover, k-fold cross validation, where this thing is specifically, friends, to cover the entire behavior of the data. Because sometimes, I can give you some example where we are studying the data, like so suppose the placement record. Okay, the placement records. Maybe I'm taking autonomous colleges, universities, deemed universities, and private colleges. Assume that. Suppose um, in the training, I have covered all these three deemed and regular universities, government universities, and autonomous colleges. But I missed out this private colleges to include in the training actually. Now, suddenly, if these private college data, if I'm giving at the testing, definitely the model could not get the statistics of this because the dimensions in the private colleges are different. Maybe if I'm talking about the autonomous universities and deemed, they are fully equipped with NAAC, NBA, NIRF kind of rankings. And generally, guys, these infrastructure is good, and so obviously at the training we may get 96 percentage of the accuracy, assume that, in the placement record verification and all. But private colleges, if I am observing like affiliated colleges and all, which are all not having any NAC or NBA accreditation, and even they are not participating in the NIRF ranking also. Obviously, guys, your model is good, but still this testing, this data is not exposed to this particular model in the training. So we may not get that much accuracy in terms of the testing phase. So that is that we can take as a best example. So how to avoid that is with the help of the k-fold cross validation. Make sure that autonomous universities, deemed and private colleges, every data, we have to segregate that particular data in a proper way. Then accordingly, you can come up with uh, proper testing and as well as the training phases. So this is how you can refer the usage of k-fold cross validation and all. Now some other solutions are also there, guys. Like if some model parameters are likely to cause overfitting, techniques for regularization like lasso, ridge is there, elastic net, all those things. Okay, L1, L2 norm, all these things can be used to penalize. Okay, at the outset, guys, regularization, penalization, and making the model simple and k-fold cross validation. These are all the simple techniques where you can make use to avoid the condition of the overfitting. Okay, which may not be completely avoided, but of course, definitely you can come up with some sort of the analogy. And moreover, guys, and before starting off any machine learning model, we are having some sort of training and as well as the testing. Now, at a time, let me pick up two topics so that we can make use of the efficient timing. So just you observe here, guys. So focus on the first question, where what is meant by training test and test set. Just now we have seen. Suppose there is a simple analogy, friends. Like suppose I'm having the data and splitting the data maybe 75-25, 80-20, likewise. Now the condition here is, friends, your 75-25 or 80-20, this major portion I am using for the training and this minor portion I am using for the testing. Okay, why it is so is simple. Like maybe I'm having some data. I'm applying some sort of the data pre-processing. Okay, and after pre-processing the data, we are going to apply some algorithm. Okay, and this becomes the model actually. This is your model. Now the point is, guys, we have to fit the model. So model fitting is nothing but the training. Once the model is ready, and we have to test the model. We have to test the model. And to test the model, friends, suppose we are having the original data. We are having our model with us, model results with us. Now what we should do? We have to test the original data with your model results. How many times your model results properly match with the original data? That is what you call your efficiency of the algorithm. Now, going back to this question, what is meant by training set and as well as the test set? We split the given data set into two different sections, namely training data and as well as the test data or training set or test set. Training set is the portion of the data set used to train the model. Just if I want to perform some kind of the um, model verification or fitting the model, then I need to give that portion of the data. Whereas the training set is the portion of the data set used to test the trained data. Testing, as I said now, guys, like there are certain aspects where if you are considering your training, X train, Y train, X test, Y test. Okay, so if you are referencing the X train and Y train, basically in the model fitting of the model, just you are giving the X train, Y train kind of thing. And whereas in terms of the model prediction, be with me, guys, model prediction, we are giving the X test, it is generating the Y prediction. Okay, your model prediction. And y test, however, we are having the original data. Now we need to compare between y test and as well as the y prediction. This is we are comparing between the y test and as well as the y prediction. Now the error must be less. Error in the sense, guys, y test minus y prediction. This value, whatever I am getting, this value should be less. Then only I can say whatever the model I am implementing, whatever the model through model, how I am generating the values automatically. If the model values are mapped with the original values, my model is good actually. Okay, for that purpose, we are making use of the train test split. Now, most important thing, guys, here is a data pre-processing technique. Maybe many at times we have seen missing value imputation, encoding techniques, standardization, normalization. All these things belongs to the data pre-processing. 90% of the machine learning engineers and data engineers works on this data pre-processing techniques. Okay, if your data is good, if your data is well managed, then obviously it is benefited to the model. In a way, we'll be getting the better predictions, right? Okay. So one of the easiest ways to handle missing or corrupted data is to drop those rows or columns or replace them entirely with some other value. Okay, that means the main issue with the null values or missing values, friends, they won't contribute anything. And in a way, they may lead to the negative implications also. So the best way is in the general thing with the domain experts, subject matter experts, we can discuss, especially the machine learning engineers or data scientists. If 30% more data items are there, like 30% more rows are having the null values, or 30% column within that particular column, if 30% of the data greater than that is having null values, then we can remove those kind of values. Provided just we have to observe that whether after removal also can I come up with a nice analogy, because we should not lose the data. Data must data must be protected because that is a source data. And if roughly if I'm dropping the data, I may not get the proper outcome. And some other techniques are also there, guys. We can use the mean value or mode or whatever, okay, as a substitution, or else you can drop the, as I mentioned, greater than 30% if I'm having drop the corresponding content, or else I can apply the default value, maybe the basic pay. Suppose if you are recruiting some 1,000 members across the India, maybe for all the freshers we are offering some sort of the package that can be taken as a default. If HR people are not aware of how much we are offering to the thing, then default we may suggest, so that they can make use of that value to fill up the data. So likewise, you can manage things, guys. And nowadays, one more aspect which is frequently used. With the help of the regression model also, you can handle the missing values. Okay, so in another session, already we have seen these kind of the things, how to handle the missing values. If you consider this missing values, actually we have seen some different approaches, guys. Very first approach is deleting the columns with the missing data. And of course, we got some 79% of accuracy here. And second thing is deleting the row with the missing data. We got some sort of 82% here. Okay. Now the third thing, filling the missing values with the imputation, mean value, median, or whatever the value. Missing value imputation. Imputation mainly specifies that whatever the information I'm having, those kind of the informations can be referred. Okay. So accordingly, you can mention the mean, median, all these values. And of course, in this example, we got little less predictions, guys, because building draw is given has given more accuracy compared with these two things, but it may not be the same case for every data. Okay, purely, the discussion also, friends, while giving the examples or while talking with the client, you should stick to the your data only, guys. That is most important aspect. And coming to the other thing, imputation with an additional column. Like maybe I can add the additional column, like whereas to handle the convention of like whether this is a missing value or whether I'm making use of any update on that. Okay, so as to convey the information, because after updating the missing values, maybe for the new user or new machine learning engineer, they may not know that whether this is a missing value or original value. So for that, you can add that additional column and accordingly you can compute. This time we got only 76.49. And the fifth model I said, no, like I can use the linear regression and I can apply some sort of the missing value imputation, and we got some better results here. Total 83, something like that, compared with your column removal, removal, mean or median update, or some sort of okay, so notification of whether this is a missing or not. So compared with all those things, just with the help of the algorithm also, I can make use of the missing value imputation. Okay, so these are all various conventions we observed earlier discussions, guys. And now if you refer, is null and drop NA will help to find the columns or rows with the missing data, and you can drop them. Fill NA, which is replace the wrong values with the placeholder value, that as I said, default values and all. Along with that, we're having some other conventions now, like the third convention is imputation with the mean, mode, or whichever, or even I can say the default value also. And next important thing is just what we have done along with the missing value update. Okay, whatever I am updating, and we have to notify with the by adding a simple column. This is also a very good idea, friend, because after some time, after working with the data, we may not know that whether the data is really that is updated or not. Last one, using with the algorithm, maybe that algorithm either linear. We have observed the linear regression. Of course, this is comparatively has given the good results among all these five methodologies. Okay, so likewise, you can manage the usage of the missing values, and which is pretty common, guys, though it is simple, but every time we are making use of the convention. Okay, let me pick some other questions. If you refer the other things, guys, these are also most frequently. I have compiled this thing as a generic way, guys, like where in many of the certification exams and many other knowledge sharing sessions, these are all very common. So ensemble learning. Generally, guys, if you consider the ensemble, what I can say is algorithm one, algorithm two, which is forming a new format. Okay, integration of multiple algorithms to form the betterment. So the ensemble learning, many base models like classifiers and regressors are generated and combined together so that they give the better results, because all the strengths of these two algorithms we are taking and we are strengthening the new model. Okay, so that in a way, comparatively, when compared with A1 and A2, A3 definitely performs well because it is integrated model of those two existing base models. And it is used when we build component classifiers that are accurate and independent. There are sequential as well as parallel ensemble methods. The specific use cases, guys, component classifiers. Okay, maybe we need some accuracy and I want to take them as independent models. Then in that particular case, we can go ahead with the ensemble learning. The best example is a random forest. Okay, so random forest is the one of the best algorithm where we can make use as a part of this ensemble learning. So here many decision trees would be there. Okay, so it is combining all the decision tree models and it is going to generate a common ensemble model, which is the random forest. Okay, so that is how you can see the random forest orientation in the ensemble. And most another common criteria always the machine learning engineers and data engineers work out is the bias and variance trade-off. You know, predictive models have a trade-off between bias, how well the model fits the data, and variance, how much model changes based on the changes in the inputs. Bias tells that in training how the model behaves, and this variance says that if I'm changing the input data, maybe I can say if I'm changing my training data or if I'm changing my testing data, how our model is getting affected. Okay, bias and as well as the variance. And simpler models like k nearest neighborhood, linear regression, all these are the simpler models which are stable. They don't vary, but they don't get close to the truth. Reason is, guys, they don't want to understand the entire data. Okay, high bias would be there. Okay, so they are very simple and high level implementation is only there, and they are never try to get the complete learning from the data. That is the problem with the high bias. Simpler models are stable. Definitely they give the, suppose if the data set is limited and you are performing some k nearest neighborhood or you are performing some sort of the regression with linear, there is not much variance actually. They are more stable definitely. But only the problem is they are highly biased. Okay, the more complex models are prone to the overfit. More complex models in the sense maybe I can take some sort of decision tree, random forest, because they consider many parameters, many hyperparameter tuning techniques we're having, and the model itself is having a big infra. So such kind of models are prone to the overfit actually. High variance would be there, but they are expressive enough to get close to the truth. Definitely they thoroughly investigate the appropriate data set in and out, and they play around with the data. But only the problem is there is a chance of high variance, overfit the data. They are very good at training, but suddenly if you are if the testing, in the testing, the problem is if unseen data or not seen data is given to that particular model, it may be entering into the zone of overfit. And there is low bias actually, but the best model for a given problem user lies somewhere in the middle. Bias and variance, that's what the trade-off. There should not be high bias or high variance or low bias or low variance kind of thing. And for this purpose, just again, managing the training and test data in a proper way, k-fold cross validation, fine tuning of the parameters. Okay, all these are major important aspects we need to consider while talking about so based on the requirement we have to specify. Now some other things, guys, maybe little advanced. Gradient descent we would have observed, stochastic and as well as the gradient descent, because this is also one of the commonly asked questions, and we have to observe the importance of this gradient descent and as well as the stochastic. This time also let me get two questions so that we can have a look. So first thing is the stochastic gradient descent and as well as the gradient descent. And another question is related to the training. How can you choose a classifier based on the training set? This is a typical, a logical kind of the question where we can observe the reference. Let us have a look on that, guys. Okay. So just if you are talking about uh, the orientation, how we can take the specification of stochastic gradients and gradient descent. Basically, friends, gradient descent algorithm or model, just it is specifies the optimization and especially to fine tune the appropriate models. Okay, so exclusively we'll discuss, guys, because gradient descent is one especially useful in the deep learning kind of thing. In machine learning also we use, but uh, these with the existing things we can manage, but especially in the deep learning and in the advanced models, definitely we have to go to the gradient. Now, both the algorithms are methods for finding a set of parameters that minimize a loss function by evaluating parameters against data and then making adjustments. This is purely, as I said, there is a optimization algorithms, guys. So they completely narrow down the parameter listing and they suggest us, okay, how to handle this loss function. Okay, so if you are able to remove the errors, then obviously you can come up with a nice model. So that is the most important thing. But the question here is, what is the distinction between gradient descent and stochastic? Now see here, guys, in standard gradient descent, you will evaluate all training sample for each set of the parameters. Um, that means, guys, suppose I'm having P1 to P10 parameters and sample all samples, maybe 20 samples I'm having 20 into 10, around 200 iterations I have to do in the standard gradient descent. Okay, you will evaluate all training samples for each set of the parameters. Okay, this is akin to taking big slow steps toward the solution. But stochastic is something like, guys, stochastic gradient descent. You will evaluate only one training sample for the set of the parameters before updating them. Okay, this is something like picking a small and quick steps to toward the solution. But the in stochastic, friends, the problem is as of course there are certain parameters or there are certain conventions where directly one can pick up the best suitable input. Accordingly, the solution we can generate. But in the gradient descent, standard gradient descent, the issue is every sample and every parameter we are mapping, then obviously there is a time consuming and extensive study we need to do. Sometimes we may not get that liberty or that leisure so as to test all these kind of the conventions. Okay, just observe that, and definitely we'll talk more on gradient descent and all. We'll try to implement some sort of the case study. Then I will see the complete narration about that. Okay, right now. The another thing, guys, how can you choose a classifier based on the training set data size? This is most generic question, guys. Like, when the training set is small, a model has a right bias and low variance seems to work better because they are less likely to overfit. So suppose I'm having only 1,000 records within that model. Probably a simple model, okay, where with a proper bias and as well as the variance also less, it is working good. And because they are less like to overfit because the data set itself is having some less data item. Whenever the data is more and in the testing, we may end up our model with the overfit kind of thing, right? Okay. For example, naive Bayes works best when the training set is large. So because naive Bayes considers all the weak learners and it is giving equal priority to all the features existing in the data. Models with low bias and high variance tend to perform better as they work fine with complex relationships. Suppose I'm having medical image data or medical diagnosis data or textual data to perform the NLP. Definitely I have to use the complex algorithms, guys. So with the complex models and algorithms, these algorithms try to understand the relationship in a better way. So that in a way, just we are going to perform the activities accordingly. So simple, if you're having moderate data, then you can always better to select the simple algorithm so as to avoid okay, those kind of high bias and as well as the high variance kind of thing, and there is no chance of overfit as the data is limited. But whereas in terms of higher data, definitely we have to select the complex algorithms, like the data itself is providing some insights. So that is one thing where you need to observe. Let us see some other questions. Uh, Actually, outlier analysis is one of the important criteria, friends, like in terms of data pre-processing and all those kind of the conventions, we're having this. Now, what I'm doing here is let me take three questions, guys, where more or less they're on the same genre. So just we'll talk about these three questions and we'll end up the talk. So now have a look on this. Just we're having these three discussions in our hand. The very first thing is how to handle the outliers. First of all, let us know what exactly the outlier. Outlier is something like, guys, suppose um, we are picking up the data from the placement team from various colleges. Okay, generally we ask CGPA and all, and for college one we got 1 to 9 CGPA, and for 10 members around we got some 10.95, 11.95, something like CGPA, where the maximum CGPA is 10 only, but we are getting the data as because wrongly, maybe the data entry operator wrongly entered the data. Instead of 7 point or 8.95, they would have entered 10.95 and 11.95. So where the data which is not relevant, which is definitely the wrong data, is nothing but the outlier. Outlier. Now there are certain methods, guys, like outlier analysis. The famous example is in the visualization box plot. Box plot is one of the best thing where if I want to find out is there any outlier really exist in our data, then we can go with the box plot. Other than that, guys, just we are having some other models. So this is Winsorized cap at threshold, because with this particular kind of the test, what you can do is we can pick up the thing like CGPA must be 7 to 10 only. Okay, then within this particular threshold only the model will observe, and to handle that convention, you can give the threshold value, transform to reduce Q. Okay, box like as I said, the box plot and all these kind of the things, just within the specification we can see that which are all the values, outliers in the corresponding data, and that too in the visualized way you can see this. Remove outliers if you are certain they are anomalies or measurement errors. You know, like this is purely the SME or uh, this domain expert or statisticians call only, guys, because we are pretty well pretty know that CGPA should be maximum 10, but we are seeing some 12, sometimes 13, sometimes 15 like that. Now you have to decide, okay, at any cost, CGPA value is 10 only, but these guys maybe due to the error, as you can see that anomalies or some errors, then definitely there are situations where you need to avoid those kind of the outliers. Okay, so many are there, but still to give the answers in the exam, or to give the answers in the some sort of the certification exam, just you can observe these three. Now, next thing is how much data should you allocate for your training, validation, and testing. This already generally a kind of thing, guys, like some people give 70-30, 75-25, and 80-20 like that. And if you ask me, is there any real impact on giving this percentage change? Definitely, guys. Sometimes 75-25 may be the best fit, and we may get the better accuracy of the model, where we may not get the things with 80-20. So it all depends. You can see, we can venture that particular thing also, whether we are able to get the appropriate information or appropriate outcome in the proper way. So definitely there is a significance, right? Okay, you have to find a balance, friends. Like there is no right answer for every problem, as as we are in the field of data science and machine learning. And there is no specific guideline for that, guys. Okay, it all depends on the data and your observation. If your test set is too small, you will have an unreliable estimation of the model performance. Definitely the testing is mandatory, guys. Uh, Again, that means 50-50 training, 50 testing, 50 we cannot do that, because majority of our model understanding is revolving around the training phase. So definitely related to the training, we have to take the testing, of course. And one important point is like testing data should not be 5% or 10% like that. At least it is minimum 20 and up to 30 it can go. Okay, so if your testing data is too small, unreliable estimation, guys, there is a biased outcome. We cannot say that the outcome is correct, and performance will be high variance, definitely compared with the training. Testing is having high variance. If your training set is too small, I mean, if it is your actual model parameters will have a high variance, guys. A general thumb rule is 80-20. And then your train test, a train set can be further split into train or validation or into partitions for cross validation. This is probably the good idea, guys, because cross validation avoids many problems. Suppose if our data is highly imbalanced and we need to segregate that particular data, and we have to give the data to our model in a full-fledged way. So in that particular case, definitely we have to perform this cross validation. Accordingly, you preserve the outcome. Okay, in training how our model is behaving, and in testing how it is behaving. Okay, now the this is something like um, confusion matrix, guys. Like, in terms of the classification, we are having a matrix. Okay, so this particular matrix gives predicted value and as well as the actual value kind of thing. There is a comparison actually. So in that we are having the terminologies true positive, true negative, false positive, false negative. Okay, so true positive, true negatives value should be high. False positive, false negative should be low. Now see here, guys, the question here is false positive and false negative and how they are significant, though they are erroneous references. But how do we handle that situation? Is there any real impact of these two parameters in our model predictions? Yes, let us see that. False positives are those cases which wrongly get classified as true, but they are false. False positive. Okay, wrongly get classified as true. Okay, they are classified as true, but reality is false. These are nothing but the false positive. Okay, the actual data is false, but your model recognizes them as true. That is a false positive. False negatives are those cases which wrongly get classified as false, but they are really true. They are true, guys, but your model recognizes them as false. So in the term false positive, the word positive refers to yes. Yes row of the predicted value in the confusion matrix. The complete term indicates that the system has predicted it as positive, but the value is negative. Really, the value is negative. Uh, False positive actually. So false positive, which is negative really, but your model find out that as a positive. And let us complete one more question, guys. Okay, so just so that we can have the discussion in the next session again. Uh, this is something like, L1 and L2 regularization, where the most important point here is your L1 norm, L2 norm, penalization, all these kind of the conventions. Okay, just we have seen actually, if you observe the in terms of regression, if you see, we talked about those things. L1 norm, L2 norm, and regularization, penalization, elastic net, all these things. But still, we'll see some other examples also. Now, if you consider the difference between L1 and L2 regularization and penalization. Friends, here regularization and penalization, which is used to handle the model performance to get the optimizations and all these kind of the conventions. Now, the question here is difference between L1 and L2. Okay, so L2 regularization tends to spread error among all the terms. Suppose I'm having the term 1, 2, term n, and this error parameter will be shared among all these terms. While L1 is more binary or sparse, with many variables either being assigned to 1 or 0 in weights. Like, in the L1 case, guys, it is something like sparse, majority of the 0. Sparse matrix is one where always we are getting the more number of zeros when compared with ones. Maybe in your high school maths and all, you would have studied the sparse matrix. So this with many variables either being assigned to 0 or 1. L1 corresponding to setting a Laplacian pair, okay, to the terms, while L2 corresponding to the Gaussian pair. So this is the terminology wise, guys, just to handle the convention. We are having the original values here. Okay, just I am making use of the split of those values and spreading of the appropriate values to all the terms. Whereas in terms of the L1, so just I'm having the sparse kind of aspect, and it is the corresponding to the working with the more number of the zeros compared with the ones. So it is bit mathematical kind of things, friends, but just we need to have the basic understanding of what L1 and L2 kind of the convention. Okay, so still some more questions we can take. Just one more. Um, Actually, if you are referencing the other kind of thing, before that we're having the Fourier and deep learning, but I want to limit our specification for the understanding of machine learning kind of the constructs. Let me give you this thing, guys. Many a times we studied about supervised and unsupervised, but whereas what do you mean by semi-supervised? Because very rarely we'll get these kind of the things, guys. In terms of the supervised, I'm having all the spam or ham detections. In terms of the unsupervised, I can say association rule mining, clustering, etc. But what is semi-supervised machine learning? So friends, here, if you are having the supervised learning uses the data that is completely labeled, whereas unsupervised learning uses no training data actually. In case of the semi-supervised learning, the training data contains a small amount of the labeled data and a large amount of the unlabeled data. I can say like Zomato, we're having some app and there are certain reviews, guys. Definitely we won't give any review or rating after our food got delivered. The general human nature. So, but with the limited reviews only, they need to pop up these kind of the hotels and all these meal, whatever the food we are ordering. Okay, just based on the rating, they should map the corresponding restaurant. Okay, so accordingly, the customer can select. But here the problem is we are having very limited data. And moreover, this data may be sometimes we may give some symbol, sometimes we may give the symbol like this. And because we want to tell, we want to give some sort of, some, I mean, feedback, but still that feedback may not be in the text or something. But in that particular case, friends, our important thing is we have to make use of the data. You see here, unlabeled data might be there, but still we need to come up with some sort of the analogy. This is how you can see the semi-supervised kind of the model. Okay, so with this, just we can have a look on these things. In further, we are going to talk about some other conventions also, friends, where these things really helps you to uh, uh, prepare and all these kind of the conventions. And one more question. So just if you are making use of this convention of naive, generally in most of the exams and most of the interviews, what do you mean by naive Bayes? And we know pretty that naive Bayes uses weak learner concept, and it is depending on the Bayes theorem that everybody can prepare. But naive, what do you mean by naive actually? So the classifier is called naive because it makes assumption that may or may not turn out to be a correct. Because our assumption here is, guys, feature 1, feature 2, feature 3, feature 10, they're all independent like that. We treat them as independent features, but practically it is not possible, guys. But logically what we'll say is just we are taking them as independent and we are trying to process them, and even weak learner also we are going to take them into the consideration. So this naive is a kind of assumption, okay, that may or may not turn out to be correct. The algorithm assumes that the presence of one feature of class is not related to the presence of any other feature. Absolute independence of the features given in the class variable. For instance, a fruit may be considered to be a cherry if it is red in color and round in shape, regardless of other features. This assumption may or may not be right. Okay, so the problem here is, guys, in naive. So simply we are assuming, and that may not be true also. Okay, so that is what how you can refer the limitation actually. So the limitation of this naive base is just we are taking that all the features are independence, but practically it may not be possible. Okay, So that's all, guys. Thank you. Thank you very much. Just you will meet you with other topics. Okay. Right.